Hello everyone. Today we're going to be doing the Physics 1PR paper from 2019 June. It's not really June, it's actually May, but okay. June it is. So here's the formulae we're going to be using. Some of these you may know off by heart, and some of these you may not know off by heart. It's easier for you to know these off by heart because then you can understand what to do for certain questions. But nonetheless, let's get past that. Okay, this question is about stars. So your late astronomy is about to kick in. Add a labeled arrow to the diagram to show which type of force from the star is acting on object A. So we know, guys, that the star, it has a mass. The star has a mass, and everything that has a mass exerts gravity, a centripetal force called gravity. So that gravity is going to pull any other object that might have a mass towards it. So my object A, because it's here, it's going to be attracted to my star. That's going to be the force acting on object A from the star. It should be pointing towards the star, if you can tell. What is object A? So, well, it cannot be a comet, because comets, guys, they have a really elliptical orbit, just like this one. So I think we can tell what object B is from this orbit. And just saying that, a galaxy, it cannot be a galaxy, guys, because galaxies don't orbit anything, especially stars. A galaxy is mostly made out of stars anyways. A moon, no, cannot be a moon, because if this guy was a Earth or planet, my mistake, my brain is acting up today, then yeah, then this would be a moon. But no, it can't be a moon. So it must be a planet. Okay, what is object B? Okay, B, so it's a comet, guys, because it has a very elliptical orbit. And it can't be any of these other things, because also planets are supposed to have a pretty circular orbit around a star. So, state the name given to a large collection of billions of stars. Okay, the name for a large collection of billions of stars is a galaxy, guys. Oops, I can't spell. Galaxy. Galaxy. Okay. Physicists classify stars according to their color. Each group of stars of similar color is called a spectral class. The table gives information about the color and surface temperature of 3 spectral classes of stars. The Sun belongs into spectral class G. We don't really need to know about this. BGM. Okay, so guys, yellow stars, if we don't understand which way it goes up in, it doesn't really matter, because all we really need to see, all we need to do is guess what temperature it would be. Now we know that yellow stars are they're not the coldest, but they're not the hottest stars. So it would make sense for our blue-white star, which is one of the hottest stars that we can get, is going to be a lot hotter than our yellow star. So let's guess a number that's above 5,600. So let's do 7,200. Now the examiner, now the examiner doesn't mind what you put as long as it's greater than the number of 5,600. You could put 5,601 and you'd get it right. It's pretty crazy. Or maybe if this examiner is having a bad day, they won't really mark yours correct, so I wouldn't really risk it, guys. Okay. So we guess what this one is, because it's an orange-red star. Red stars are one of the coolest stars you can get. So orange and red, they're going to be probably less than this, so let's say 2,500. Yeah, 2,500. Okay, there are stars in the universe with masses much greater than the sun. Describe what happens to these high mass stars when they leave the main sequence stage of their evolution. Okay, guys. So, what the examiners really want you to say, there's 3 main points they want you to say, and they want you to say the key terms of a red supergiant. So, star will become supergiant. A red supergiant, actually. Red supergiant. Then the star will explode. The star will leave either a black hole or neutron star, depending on its size. There we go. Yeah, you have a lot of lines here, and that's probably because a normal person would not say this little. Probably they say the star will become a red supergiant once it has run out of its helium fuel, hydrogen fuel for nuclear fusion. And when that happens, the star will expand. Well, first it will collapse on itself, and then this causes high temperatures inside of the star. So this causes the star to enlarge again, and then because the outward force becomes greater than the inward force of gravity, and then this will start deciding, oh, hey, I'm going to start fusing helium fuel now. So it starts doing that for another few years, and then after that, when it runs out, it will collapse on itself and create a black hole or neutron star. Okay. Some of the nuclear energy stored in the nuclei of an atom can be used to generate electricity. A nuclear fission power station generates electricity. State the role of the moderator in a nuclear fission power station. So remember, guys, that the moderator is used to slow down neutrons so they can successfully collide. Now, you're allowed to say slow down neutrons, but I think the examiner prefers you to say things relative to energy source. So let's say the moderator is used to reduce the kinetic energy store of the neutrons. Neutrons. And if you want, hence slowing them down. If you want, you can say all of that. Okay. Some of the daughter nuclei produced in the nuclear fission are highly radioactive and emit high energy neutrons when they decay. Explain which feature of a nuclear fission reactor reduces the risks of these. Okay. So, well, there's 2 things. We could use control rods. Rods absorb excess neutrons. Therefore, absorb excess neutrons. Then another thing, guys, there's only 2 marks. Don't know why we have so many lines. is that we have lead slash concrete lining. Shielding maybe would be better. Shielding to prevent radiation from escaping from irradiating. Others, maybe. Okay, the daughter nuclei can cause contamination and irradiation. State the difference between contamination and irradiation. Irradiation, guys. Well, we should start with contamination first. Contamination is when a non-radioactive object comes into contact with a radioactive, can't spell, active material. Irradiation is when how do I spell irradiation? That's right up there. I should probably. Is when an non-radioactive object is exposed to radiation. I can't type properly, guys. I'm so sorry about that. So radiation is when a non-radioactive object is exposed to present radiation. That's definitely not how you spell radioactive. There we go. Okay, next one. Nuclear fusion is another process that could be used to generate electricity. Describe the process of nuclear fusion. Okay, nuclear fusion, guys. Nuclear fusion is when two smaller nuclei fuse. Am I allowed to say fuse? Create a larger nucleus. This, okay, the overall product mass is less than the initial mass. Of the, not reactants, but original nuclei of the combined mass of the, okay, the overall product is less than the initial mass of the combined original nuclei mass. Okay, then we say this loss of mass is converted into energy. No. Released as energy. Released as energy. There we go. Okay. State where nuclear fusion. Well, this one's a star. You can just say star, guys. Generating electricity from nuclear fusion is very difficult for conditions aren't. Yes. Well, you have to explain a lot of things, guys. You have to talk about how you have to talk about how high the temperatures need to be and why they need to be that high. And then we need to talk about the pressures and why they need to be that high. And there's also one thing else we could also, no, that's for another question. My mistake, guys. So what we have to say, guys, is that high temperatures and high pressures are required for nuclear fusion to take place. Okay? This is because the nuclei need to have high kinetic energy to be able to overcome the this is because the nuclei need to be close enough together to be able to fuse. Fuse. Or collide. Be able to collide. As the nuclei repel each other, due to them having similar charges, then they need to have high kinetic energy to overcome the electrostatic repulsions. There we go. That was all 5 points. But when in doubt, say all 5 points. Just in case. So high temperatures and high pressures are required for nuclear fusion to take place. This is because nuclei need to be close to each other to be able to collide. As the nuclei repel each other due to them having similar charges, they need to have high kinetic energy to overcome the electrostatic repulsion. Whatever. State what this is meant by an isotope. An isotope is an atom that has the same number of protons but different number of neutrons. Hence, their different mass number. How many protons are in the nucleus of lead? 82, guys. It's always the smaller number that tells you. Rub that out. I could be doing a different color, guys. I never realized. Okay, here. A. It's A. Okay. A sample of lead-220 has an initial activity of... Okay, Becquerels, guys. So, what we need to do is... This is probably our first... Yeah, for some reason, we're on question 3. This is our first equation in physics. On a physics paper. It's weird. Anyways, it has an initial activity of 240 becquerels. 30 becquerels is, after 66 years, the activity of the sample is 30 becquerels. Okay, we need to find the half-life. So guys, first we gotta count how many times we're going to be doing our half-life of lead-210. So here's our first half-life. This equals to 120. Then our second half-life is 120 divided by 2. 120 divided by 2 equals 60. And our third half-life is 60 divided by 2. 60 divided by 2 equals 30. So that's 3 half-lives. And this all goes into the span of 66 years. So, guys, we have 1, 2, 3 half-lives. So we're going to do 66 divided by 3. 66 divided by 3 equals 22. And that's our half-life. 22 years. Okay, next. Lead weight. Well, I can't read this number for some reason. Okay, lead 210 decays into lead 206 through a number of stages. This involves 1 alpha decay and a number of beta decays. I see. Okay, so guys, you need to know the alpha particles proton number and mass number off by heart. So it's 2 and 4. And if something's gonna lose 2 protons, and then it's gonna want to lose its electrons. So how many? If we've lost 2 protons, it's gonna lose 2 electrons as well. So there we go. Complete the equation by. Oh, that's what we did. Okay, next. Oh, that's a really nice swimming pool. The water in the swimming pool is heated by the sun during the day. State how energy is transferred from the sun to the water. Guys, we can just say IR radiation. It's just that simple. IR radiation. That's what we say. State what happens to the average speed of the water molecules as the water is heated. The water molecules increase in speed. The water in the swimming pool cools down at night. Suggest why the water cools down at night. Well, the swimming pool, guys, we should say, I should tell you guys that the swimming pool is hotter than the environment. When something is hotter than the environment, it likes to it likes to emit more radiation than something that is cooler than it. When something's cold, it likes to absorb more radiation. It's like that. So the swimming pool is hotter than the surroundings. Oh my god, how do I spell surroundings? Oh, the environment around it. Therefore, it will emit more radiation therefore it will emit more radiation. Okay. So, the next one, explain why the plastic cover. Okay, so guys, there's a lot to talk about here, about 6 things to talk about. So, we have the trapped air becomes trapped. Now, we can talk about when the cover is put on. This creates an insulating layer of air, which is a good insulator. The cover is made out of plastic, which makes it a good insulator as well. The cover, because the air is trapped, no convection current can take place. We can also talk about the good insulation reduces the amount of conduction. Oh my gosh. Come on. Okay, no convection current can take place. And because the surface of the pool is the surface water of the pool is concealed, therefore no evaporation can take place. Kaboom. We got all 6 marks, but it was a 4-mark question, but we wrote way more than we needed to, but it's better to be safe than sorry. That's what I had to learn that the hard way, I swear. I have to admit that that is a very good thing to say. Okay. Oh gosh. Okay. I don't know if I can do this question because I need to measure it. Guys, if you have the actual paper in front of you, then you can go measure it yourself. But this guy is supposed to be around 3.7 centimeters. But it says to determine the mean diameter. So you can measure the thing like 3 times. I'm going to measure it 3 times, and by measuring it 3 times, I'm going to just, oops, this is supposed to be a plus. I'm just going to come up with random values. Plus 4 plus 3.5 equals, oh, why did I make it so hard? Okay, so that's going to equal to 11.2. So 11.2 divided by 3. I can't do that in my head. It's going to equal to, yeah, it's a third, equals to 3.8. So 3.8 centimeters. That's what it should be. That's the mean diameter. Okay. So guys, if you like maths, then you don't really need this. Let's say that we're just let's test ourselves. So pi r. This is supposed to be pi. I don't have pi on my keyboard, so I'm gonna have to write it. Pi r squared. Not the hardest. So we're trying to find the cross section, guys. Don't get confused. This is a cross section. Like we just cut this thing in half. That's a cross section. That's the cross section. So yeah, guys, remember this is the radius we're using, not the diameter. So be careful. You don't want to accidentally use the diameter instead and get the wrong answer. So we're going to do 3.8 divided by 2. That's going to equal to 19. So we're going to do pi 19 squared. So pi times 19 squared. What does that equal? That equals to 361 pi. So what the heck? That's definitely not the answer. Oh, what did I do wrong? .9, my mistake, guys. I put 19 because I was thinking of 38 divided by 2. Oops. No, that's definitely not 19. Anyways, there we go. The answer should be 11. 11.3. That's why I advise to use your calculator, not use your brain for these questions. Because if you have a calculator, And if you have a calculator, you're allowed to use your calculator, then use that to your advantage, guys. Don't think of it as a making yourself look weak. You will look a lot weaker when you don't know what 3.8 divided by 2 is and you say 19. Okay, try to make your exam foolproof. Okay, so there's that. Yeah, that's the right answer. If you guys came up with a different answer for this one, and you didn't come up with 11.3, that's okay, as long as your answer was 9.6, between the ranges of 9.6 or 12.6 centimeters cubed. Okay. The student connects a cylinder to put it to a battery. He measures the voltage of the cylinder and the current in the circuit. Complete the circuit. Okay, guys. So he wants the voltage and the current in the circuit. So he wants to measure that. Guys, remember though, be careful because I see a lot of people get this wrong. People put the voltmeter in series and the ammeter in series as well. Don't do that. The voltmeter, remember, always needs to be in parallel with what you're measuring. So we can do here. This is the voltmeter. V. It's supposed to look like that. And that is going to be A. An ammeter should be connected, but it's not so easy when you're doing it like this. Okay. That's what it should look like. The ammeter can be here. And even the voltmeter can be in parallel with the cell, but that's condoned, guys. Yeah. Okay. So a student uses the voltage. Yeah. Okay. This is another calculation question. Don't know why they gave us such little space to work with, but here we have V equals IR. So V equals IR. That's our equation. So we have our voltage, it's constant, which is really nice. It doesn't happen all the time in real life, but there we go. Current in A. So we're gonna have, to find out R, we're gonna do V over I. So that's going to be 4.56 over 0.107. That's going to equal, get your calculators out, guys, because if you try to do this in your head, congratulations if you manage to do it in your head correctly, because I got 42.6168223. So yeah, I like to put my answers to one decimal place. Usually it likes you to say like 43 or something, but no, actually for once it wants you to put 42.3. Oh, it makes sense actually, because this is the trend is to do that. Yeah. Okay, so that's the answer. Plot the graph of resistance. Okay, on the y-axis and the cross-sectional area on the x-axis. Okay, it's nice that they're telling us to do that. Okay, so guys, I can't draw a straight line. And I can't write sideways as well. Maybe if I do it like this. It's okay. Cross-sectional area in centimeters cubed. Just put it there. And this is going to be ohms. Resistance in ohms. And what's going to be the best? Let's do 5s. Okay, so 5, 10, 15. It's not very pretty, guys. I'm so sorry. 25. Yeah, okay, nice. Then, guys, we put these the wrong way around. I'm so sorry. I'm so stupid. Ah! how do I? Oh, I think I know. No, even Control Z doesn't work, guys. I messed up really bad. Don't do that in your test, guys. I'd be sure I would be the one doing that. Okay, there we go. So, here we do 5 tens. 5 10s, 15 20s. I'll just write it here now. 5, 10, 15, 20. I don't know what I was thinking, guys, honestly. 25, 30. Anyways, this guy, the independent variable always goes at the bottom. So, yeah, here. Okay. Let's do this. Yeah, okay. So this is not really ideal for me, is it? Because I have to keep scrolling back up. But the curve should look like just put that there so it's easier for me. Okay, so 91.2. That's gonna be like well, I'm gonna put it like I'm gonna guess, guys, because honestly I'm not gonna be greatly hugely bothered. Yours better look better than mine though, because you can actually do this a lot easier than me. Just gonna draw where it roughly is. So it should, the curve should look something like that. At least drawn a little bit better than mine. Let me try that again, guys. Yeah, that more like that. Yep. Next one. I don't like that one. Okay. The student decides to extend his investigation by adding 2 identical cylinders to a battery. Let's discuss how the measurements of his. Okay, so guys, he has now got a parallel part. The voltage. Let's talk about the voltage first because that's the fastest. The voltage should stay the same. I'm not writing that with my pen. Oh my god, that'd be horrible. Okay, the voltage will stay constant throughout the previous will stay the same compared to the previous circuit. Okay, we have a lot of lines here, guys. We can work with this. There are only 4 points to really say here, anyways. Okay. Each cylinder is so, guys. Just saying that when something is in parallel, they will like two things are in the same parallel. They will share the amps that go through that one branch. But these two guys, they require the same amount of energy. So each cylinder is connected in parallel from the cell. The total current increases by double because the current in each putty should stay the same as before because they are the same component, guys. They require the same amount of electricity or amps, amount of current to run. I say run with quotation marks because they won't really do anything, to be honest. They're just conductors. So the putty's kind of like a resistor anyways, to be honest. So these we should put hence. I like putting hence. Hence the currents in the putty cylinders will add together. So if we had a third one, guys, in parallel as well, then it would thrice it, basically. It's pretty cool. That is a nice shiny ball. A photograph shows a small glass ball to investigate density and pressure. The mass of the ball is 19 grams. The density of the ball is 2.3 grams per centimeters cubed. State the formula. Okay, so guys, the formula is density equals mass over volume. Calculate the volume of the ball. Okay, guys, the volume of the ball, we have 19 grams. Thank God we only have to do this in grams per centimeter cubed. So 19 grams, and the density of the ball is 2.3 grams per centimeter cubed. Okay. So we have our mass, guys, and we have our density. So we need to rearrange this question so that we have density under mass, and that will equal to our volume. So our volume equals to 19 divided by 2.3. I'm putting that in my calculator, guys, because it's another very big number. I'm going to do 8.3 centimeters cubed. You can round it to 8, but I like it to be to one decimal place. Okay. The ball is dropped into deep water and sinks to a depth of 560 centimeters. State the formula linking to pressure difference, height, density, and gravitational field strength. Okay, guys. Here. Okay, so let's do this. So pressure difference equals height times density times gravitational gravity. I'm just going to say gravity because I'm not going to. I don't feel like writing it. Calculate the increase in pressure of this step. So guys, now we're using kilograms per meters cubed, and we're also going to be combining centimeters, and that's not good. We shouldn't be combining centimeters. So we're going to convert our centimeters into meters. So we're going to do 5. So what we're going to do? The increase in pressure. So that's going to equal to 5.6 because we need to 5.6 because we need to divide this by 100 to get meters. 5.6 times 1000 times gravity, which is 10, and that's going to equal to 56,000 pascals. Okay, okay, this is not going to be hard. This is not going to be easy, sorry. But, that's okay, guys. because I can't draw it, but that's fine. You know what? I'm not drawing that. So guys, I gotta draw one for you so it makes more sense. This is a ramp, guys. Just saying. Um, we can use a protractor. This is supposed to be material. This is supposed to be the block. This is supposed to be the light gates. These are supposed to be computer. There's supposed to be only 2 light gates. Sorry, guys. Connected to a computer. And yeah, tape measure, stopwatch, boom. Okay, guys, it doesn't look like a good drawing, okay, but I'm gonna be honest, it doesn't look too much different from the one that I drew on paper. So all we really need to talk about is this. So we're gonna talk about the measuring equipment. So measuring equipment we will be using is a tape measure and a stopwatch. Then we're going to be detailing the dependent, independent, and control variable. So our independent is the material that of the slope. Yeah, the surface material of the slope. Independent. IV, independent variable. Dependent variable is the speed that the block travels, and the control variable can be whatever you want as long as it makes sense. What I'm gonna say, guys, is the gradient of the slope. Then, but you can also say, guys, you can also say the distance that the block travels, or the starting point of the block. What else could you say? The material of the block, maybe. Material of the plane, this part here. Yeah. Same room, same air resistance, stuff like that. I don't think anyone would really think of that. Let's see, what else is there? How the average speed will be determined. Okay, this is your last mark, guys. 1, 2, 3, 4, 5. Yeah, our last mark. Just say you can use the equation. You can substitute the findings into the equation. Speed equals distance divided by time. There. Cool. Next, look how many lines it offers you to write on, and you just this makes it easier for the examiner, I think. Justify why the student should display their results as a bar chart. Now, guys, it may be hard, you probably know why, but it's hard for you to word, and this is what I say. This is what I say. The independent variable is categorized categorical, which basically means that the IV is dependent on is basically like categories. You can't really, it's not really an increasing number. You can't really increase, like, maybe you can increase something, the surface's friction, but then that's like a whole different thing you need to do. So it's probably easier to just say cloth or cloth, wood, etc., rubber. Anyways, that's it, right? Okay. At point A, the parachute jumper is falling at terminal velocity and has not yet opened her parachute. Which statement is correct about the parachute jumper at point A? That's better. That's better. Okay. Which statement is correct about the parachute jumper at point A? So the parachute jumper. Okay. Well, we first have to look at this. Acceleration and air resistance are equal. No, because that's kind of acceleration has nothing to do with equal. If it has acceleration and it's not right. Yeah, here, there you go, that one. Because the forces are balancing each other out, guys. When the forces balance each other out, well, this thing's not gonna move. Not gonna move at all. So, there we go. My beautiful drawing. When something accelerates though, guys, this means that the forces are not balanced. Also, the skydiver, guys, is just because they have a balanced forces, right? Doesn't mean that she's gonna just fall. She's gonna stop falling and instantly like come to a halt and get stuck in the sky. No, sorry. It's basically like she doesn't move. She doesn't. She does move, but she's like stuck at a constant velocity. She's not accelerating anymore. Is that she or a he? We don't know. The parachute jumper? We don't know. Okay. Which is the following best estimate of the distance fallen by the parachute jumper from start until point A? How do I get this going or whatever? Okay, guys, so really all we're gonna do is kind of be lazy. Usually, in velocity time graphs, the only way you can find you can only find distance by finding out what the area underneath the graph is. But we don't know. Like it's curved. Ah, damn it. So, what are we gonna do? I'm just gonna make this a square. This entire thing is square. So, well, let's make this. Here, here, like here. Okay. 1, 2, 3, 4, 5, 6, 7. So this is going to be 7. 7 times 4. 2 is equals to 4. So it is 40 times 40 plus 14. That's going to be 54. Here. And this is going to be, yeah, 50. So 54 plus 50 times 50. 54 times 50, guys. Equals 2,700. What? 2,700. So, guys, I know this is one of the answers here, but don't put it as this answer, okay? Because we know that this is definitely a lot more, because we have this entire thing included as well. So, it's not going to be 2,700. It's not going to be 2,700, guys, because it needs to be smaller than 2,700. So we're going to guess this one, because it's less than 2,700, but it's also closer to 2,700. So it's the closest answer that, yeah, okay. Next. Okay, yeah, there's lots to talk about in this one as well. Where is my, okay, here. The parachute jumper opens her parachute. Okay, so when the parachute is released, the air resistance increases exponentially. Kind of kidding me? Exponentially. Ah, okay. You learn something new every day. This, when, because there, guys, because, I'm just gonna write that, I'm gonna write in full sentences now. Because the air resistance was balanced with the weight force. Now it is now going to be greater than the parachuter's weight. Therefore, this will cause them to decelerate. But guys, she will start decelerating at decreasing rate, right? Because air resistance depends on the speed you're going at, because it's the collision with air particles, guys, and the surface area you have. So the bigger your surface area, the more air particles you're gonna hit. The faster you're going, the more air particles you're gonna hit in the same amount of time of something that's traveling at smaller speed. So if they're going to go slower, because they're going to start going slower though, guys, because the air resistance is basically accelerating upwards now. So they will at a decreasing rate. This is because the slower the jumper goes, the less air resistance there will be, causing there be. Eventually, it will the resultant force will become 0 again, and the jumper will go back to terminal velocity. There will be no more accelerations. Yeah. After point C, the parachuter continues to fall at a constant velocity. As she falls, energy is transferred to her. So guys, remember, I actually fell for this. It's not this one. It's not this one. Okay. Usually when you fall from a height, your gravitational potential energy decreases as it gets converted into kinetic energy. But because she's at the jumper is at constant velocity, she cannot be getting this converted into kinetic energy store. So it will be going into her thermal energy store. Guys, I should probably explain why it's not chemical, because there's no I don't know. There's no, I don't really know what to say. There's no chemical reaction taking place. Um, it's not gravitational energy store because that's what's decreasing. It's not kinetic energy store because she's at constant velocity. Therefore, it must be her thermal energy store. Process of oh no. How am I going to do this? Okay, guys, this is a light ray, just for your information. So it will be going slower. That's faster, my mistake, guys. Like this. These guys should be a lot closer together. Okay, like that. So it should look like this. Uh, yep. So, maybe it's the wrong way around. I don't know which way is the right way around. Anyways, explain what happens to the wavelength of light when it passes from air into water. So, the wavelength decreases because the wave decreases in speed and its frequency will stay the same because it's gonna be the same light. At the normal. Oh, are you kidding me? I'm trying to be as straight as I can. That would not get me the mark, but you get the point. It's supposed to go through here. Measure the angle of incidence is here, guys. So you measure it yourself. Oh, what did you get? 55 degrees Celsius. Okay, degrees Celsius. 55 degrees. My mistake. Okay, guys. So calculate the critical angle for the. Okay. So we have refractive index, which is n, and we are looking for critical angle. So this is going to be n equals 1 over c. Ha! No, 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 no. Sorry, this is going to be sine c equals 1 over n. My mistake, I messed them up. So that means c will equal to sine, inverse sine of 1 over 1.6. What is that going to equal? No, 38.6. We're going to put 38.7 degrees. Okay. Explain the path of the light ray shown in diagram 2. So guys, because this is at 55 degrees, and this is in glass, by the way, guys. So what's going to happen is there will be total internal reflection because the light is traveling from a higher refractive index to a lower. The critical angle is less than the angle of incidence. hence total internal reflection. Okay. This question. When does this end? My voice is starting to hurt. Okay. The van question. So force X opposes the motion of the van. You can name this. Yep, that's right. Air resistance. The resultant force acting on the van is 1,500 newtons. So calculate the magnitude of force X. Force X is the smaller one. So hence this is probably it's probably trying to take off some of this. So we have 2,500 minus 1,500 equals 1,000. So force X is 1,000 newtons. State the formula resulting linking to resultant force. Okay, so F equals ma. Speed run. The mass of the van is 1,900 kilograms. Calculate the acceleration of the van when it brakes. Give the unit. 14,000, guys, because we're timesing this by 1,000, so we can get into newtons. And that equals to 1,900 A. So we're going to do this, and that equals A, meters per second squared. 14,000 divided by 1,900 equals 7.4 meters per second squared. The van is traveling at an initial speed of 18 meters per second before braking and coming to a rest. Calculate the distance traveled by the van while it is braking. Okay, so guys, this is to do with the equation. So we have 18 minus 18 squared. 2a. A is times s, which we don't know. So what we're going to do is negative 18 this equals s. So we should also put this as an acceleration, guys. Sorry, my mistake. You know why? Because it is braking. It is losing velocity, so therefore it must be minus. Okay, so negative 18 squared over 2 times negative 7.4. That's going to equal to S, which is 21.9 meters. Describe 2 factors that would increase the braking distance. You can come up with anything here, guys. Any that you desire, as long as it only affects the braking distance. Well, not only, it could be speed. It could also, yeah, you could also do speed. So, I'm going to put the increase the braking distance. The traction of the road was bad traction of the road and tires. If the road was icy. Another one is worn out brakes. There we go. When the van is fully loaded, it's best to. Okay. What do we want to find out, right? Time taken now. So now we have this. Yeah, we're gonna have to find out. Yeah, we're gonna have to find we're gonna do F equals ma to find the acceleration. So we have our F is 14,000. again, it's still the same, and that's going to be over 2,500. That's going to equal to our mass, no, acceleration, 14,000 over 2,500. That equals to 5.6. Actually, we're going to put negative this and negative that. This is actually negative 14,000 because it's, remember that this is going the other direction. We're trying to oppose our thrust. And then we have what we're trying to find, time taken. So then we can do an initial speed of 18 meters, so that's going to be negative 18 over time, which we don't know, equals negative 5.6. So what we're going to do, guys, is we're going to do the same thing. We're going to swap these guys around, equals t. And now, what is our answer? I can't see, it's so dark right now, guys. Okay, we're going to have to round that again. 3.2 seconds. Okay, last question. Okay, a student, okay. We're not going to draw the diagram, we are. This is a bar magnet, guys, S, and this is, I'm going to put a bunch of things here. These are iron filings, it's supposed to be. Here's a piece of paper, piece of card, whatever, and here's a compass. Okay, this is the easiest way. I swear this is the easiest way, guys. I always explain it this way and I get full marks. Okay, so sprinkle some iron filings on a card with a permanent bar magnet laying on top. Tap the card until the iron filings form the pattern of the magnetic field. That's how we're going to find the shape of the magnetic field. The direction, we can find the direction of the field by moving a compass around the magnet. It will point in the direction of the field. Perfect. Okay. Yeah. Okay, let's add 2 arrows to the diagram to find. Okay, so let's just do this and this. I think would be the best place to put them, as long as they're correct. Explain how the diagram shows that the strength of magnetic field changes. Guys, if you didn't know, the spaces between the lines determines the strength of the field. So if there's like little space between the lines, that means it's really strong there, and it's really weak with the places where there are really big gaps. You see, like here, 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 wow, big gaps. Okay, so we can see that the closer the field lines get closer as you get closer to the ends of the magnet, get closer, not closer, narrower as you get closer to the ends of the magnet. the two ends of the magnet have the strongest magnetic field as the lines are the closest. There. This is because the two poles are present in that area. Okay guys, this question's annoying. So yeah, we have to pick 2 points from this graph, and we need to see if they add up, and we need to implement this into this equation. If it equals a constant, then these results will obey this relationship. So let's pick these points right here. 1, 2, 3, 4. So 5.4 times 20 squared times 20 times 20 times 20 equals 2,160. Let's go to the next one. 0.4 times 70 times 70 equals 1,960. So these guys are not the same. Now you may say that because they are supposed to be in milli Teslas, if you put them into Teslas, they would be 2.1s, that would be 2.2, and that would be 2. And the difference is very, very small, you could say, and therefore you could be very nice and accept that it does support the conclusion. But I'm going to be mean, guys, and I'm going to say that the constants, different pairs of readings do not give the same constant. Therefore, the students' results do not support this conclusion. And there you have it. This entire paper is done. Now we're going to do paper 2 next. So you guys better get ready for that. Yeah, there we go. Hope you enjoyed this video. And yeah, goodbye.